Hello. So, in the last chapter, we did Newton's first law of motion. So, today we will do Newton's second law of motion. Okay. So, before that, let's study about mass and the difference between mass and weight. So, mass is actually a quantity of matter. Okay. And it's the basically the measure of inertia. It's the measure of inertia of an object. Okay. So the more the mass is, the greater force is required to give it a particular acceleration. Suppose this is a block of 5 kg, and suppose this is a truck weighing 1000 kg. So the greater the mass, the more force is required to move. Suppose this truck, we need much more force to move the truck than to move this mass of 5 kg block, uh, block of 5 kg mass. Okay, so it is so a truck has more inertia than the block, and very much greater force is required to change the truck's velocity. And okay, so it is the mass is the measure of inertia of an object, and weight. So mass is a property of an object itself. So it doesn't change with the place we take. Mass is the property of an object itself. So if a mass is taken to a different place, if an object is taken to a different place, the mass, the value of mass doesn't change. It keeps, it is same. So weight is basically, it is a force, or we can say force of gravity. Okay. And it's also called mass, and it is equal to Fg is equal to mg. Okay. So mass here means the gravitational mass. Okay. So gravitational mass is the mass which we use determining force of gravity acting on an object. Suppose this block lying on a table, and we find its weight or the force of gravity, then the mass we use here is known as the gravitational mass. So the weight is basically the pull of gravity. Okay. It is a pull of gravity which is acting on an object. So if we take a small block here, which is 5 kg mass. If we take it to moon, it will, or to a different place from the Earth, it will weigh different because it depends on G, which changes. Okay, but the mass remains the same. The weight, it changes with the place. So as mass is the property of an object itself, it remains same, whereas the weight is the force of gravity, or it is the pull of the gravity acting on an object. Okay. So, if the object is taken, same object is taken to the moon, it will weigh only 1/6 because the gravity is, because G is, because F, G, and G, because mass will remain constant, but the gravity is 1/6 on moon as compared to Earth. Okay. And so the inertial, the gravitational mass, it is the mass which one uses when determining the force of gravity. And what is the inertial mass? So inertial mass is the tendency of an object to resist and change in state of motion. Okay. So inertial mass is the tendency of an object to resist and change in state of motion, whereas the gravitational mass is the one uses determining the force of gravity. So, and the gravity on the Earth is 9.8 meter per second square. And all forces are vectors, means they so they have a magnitude and direction. So force of gravity or weight is also a vector and its direction is down. Okay. So, so if a block is lying here and if a net force is exerted on the block and it is in the direction of motion, suppose this, then and a force applied is in the direction of motion, okay, or velocity, we can say, then the velocity will increase. Okay. And if a force is, if the net force is in the opposite direction to the motion, suppose this is direction of motion or velocity, and the force applied is in the opposite direction, then the velocity decreases. Okay. And if the net force, if this is the direction of the motion and velocity, and if the net force is given sideways, is applied sideways, this, then the direction changes. Okay. So the acceleration of an object is directly proportional to the net force acting on it. So acceleration of an object is directly proportional to the net force acting on it and is inversely proportional. To the mass of an object. Okay. And the direction of the acceleration is the same as the direction of the net force. So this is the net force and this is mass. Okay. So this is Newton's second law. Okay. This is Newton's second law of motion. Okay. And the units for the mass is in SI system. The unit for the mass is kg, kilogram, and in CGS it is grams, and in the British system it is slug. Okay. Whereas in force it is newtons, and this is dyne, and this is pound. Okay. Now, so force is, it doesn't mean that we apply the force and it will accelerate. Basically, the net force, if the net force is there, then only it will cause acceleration. So force is an action capable of accelerating an object. Okay. So, and it is a vector, and this equation This equation is valid in any inertial reference frame. So force, so let's do a problem like what is the net force to accelerate a 2000 kg car at 5 meters per second square and a 200-gram ball at 5 meters per second square. Okay, so net force to accelerate a car, it is ma. So this will be 10,000 kg. Okay, so it will be, I'll show you the steps. So it will be m times a, means 2000 into 5. So 10,000 kg meter per second square, or we can say 10,000 newtons. Okay. And for this ball, first we will change the grams into kg. So it will be, it is MA, so 200 times 10 raised to power 3 into 5. Okay, so it will be, okay, times 10 raised to power, so 1 Newton. So we can say that a very large force is required to accelerate a car as compared to the ball, which is much lighter. Then in one more problem we can try is which uses equations from kinematics, and kinematics equations we use when the acceleration is constant. So it is what average force or average net force is required to bring 2000 kg truck to rest from a speed of 200 kilometer per hour within a distance of 55 meters. Okay. So we see what is available here. Okay. So what is the initial velocity? V initial, it is 200 kilometer per hour. So we will change it into meters per second. So it will be 200 into 10 raised to power 3 into 60 into 60. So this will give us 2 into 10 raised to power 5 and 36 into 10 raised to power 2. So this will give us 55.5 meters per second. Okay. So this is our initial velocity with which the truck is already going. And the final velocity, we want it to bring it to rest. So final will be 0 meters per second. And the distance here is given 55 meters and the mass is given as 2000 kg. Okay. So V final square is equal to V initial square plus 2AS. Okay. This is the equation from kinematics which we used, and it works on the constant acceleration. So here is the constant acceleration. So this equation we are using to get A, because you know what is the equation of F, which force which we are trying to find out is ma. So we know m, but we don't know a. So to find the acceleration, we'll use this equation. So final velocity is 0. Initial was 55.5 plus 2a we do not know, and s is 55. So when we solve this equation, we get acceleration as negative 28.05 meters per second square. Okay. So F here is equal to ma, which is 2000 kg times negative 28.05. So this is equal to negative 561 0 newtons. Okay, negative sign here means that force must be exerted in the direction opposite to the initial velocity. Okay? And the acceleration is constant. So we can also write like force is like this is the truck that was moving initially with the velocity. Okay, so we can write negative 56100 newtons, or we can write 56100 newtons west. Okay, and the Newton's second law, like the first law, it works on the inertial reference frames. In non-inertial reference frames, like the cup on the dashboard of the car, uh, and it starts sliding. So even though the net force is zero, but the cup lying on the dashboard here still slides when the car is moving or starts moving, and there is no force on the cup. So in the accelerating reference frame, Newton's first law doesn't work. It works in the inertial reference frame, like the first law itself. Now, let us do another problem which uses a small, easy free body diagram. Okay. So when we apply a force of uh, 5 newtons, suppose this is a book lying here. Okay. It's a book. So we apply a force of 5 newtons horizontally to a 1500-gram book. Okay. And that is resting on a table, lying on a. So if the force of the friction, if the force of friction between the book and table is 3 newtons, okay, then magnitudes, write the magnitudes and direction of all the forces acting here. Forces acting on book. okay, and the acceleration of the book. Okay, so force applied here is 5 newtons. Okay, we can say force FA on the book. Okay, and the mass here is 1500 grams. So we can change it into kg. So this gives 1.5 kg because Newton is kg meter per second square. Okay. And the force of friction which opposes motion, so it is always in the opposite direction to the motion, it is 3 newtons. Okay. So now if we draw the free body diagram, so this is a force of gravity which acts down because of the gravity, and there is a normal force which is a contact force due to the surface which is Fn. Okay, then there is force applied. Okay, this is force applied which is 5 newtons, and the force of friction which opposes the motion always, so it's in the opposite direction, and it is less than force applied, so a smaller arrow, and this is force of friction, 3 newtons. Now, the sum of the forces in y direction would be Fy is equal to force normal minus force of gravity. Okay. Because we know that neither it is going up nor it is going down. So net force in the y direction is 0. So we put it 0. Okay. And both are in the opposite directions. So Fn is equal to Fg, which is Fg is equal to mg. So m was like 1.5 into 9.8. So it is about okay. So it is about 14.7 newtons. Okay. Now, so normal force is about 14.7 newtons. Direction is upward, and force of gravity is 14.7 newtons acting downwards. Now the net force in x direction, so that would be Fx is equal to 5 in towards right and 3 towards left, force applied minus force of friction. So this is 5 minus 3. So it is 2 newtons. Okay. Now, net force in the horizontal direction is responsible for given acceleration. Okay. So it is m ax. Ax means acceleration in the horizontal direction. So this would be Uh, so acceleration would be equal to sigma F over m, which is 2 over 1.5, which means 1.33 meters per second square. Okay. So acceleration is in the east direction here. So we can say 1.33 meters per second square or 1.33 meters per second square east. So we see the acceleration is directly proportional to the net force and is inversely proportional to the mass of an object. And they are both are always in the acceleration and the force. Net force are, are always in the same direction. Okay. So if the net force increases, acceleration also increases, keeping the mass same. If mass increases and the net force is same, then the acceleration will decrease. So if velocity and force, they are in the same direction, then it speeds up. And if velocity and F are in the opposite direction, if they are in opposite direction, then it speeds down or its speed is becomes less. And if the force and velocity, if the force is perpendicular to the velocity, like the motion, the direction of the motion, and if the net force is applied is perpendicular to it, it neither speeds up or goes down. It changes the direction like this. Okay. And it keeps on moving like this. Okay. And when the velocity and force they come in the same direction, then it starts speeding up. So at a point, it's not speeding up or not. It's neither speeding up or down. But at B point, when they both are in the same direction, then it starts speeding up. So now we can do one more problem to make our concepts more clear. So if there are eh, three kids, if three kids, namely A, B, C, okay, and they are pulling a toy, okay, with horizontal force, Okay. So and they it's it's lying on a table, like this is a horizontal table. Okay. And the toy is lying on here. And if it is pulled by three kids A, B, and C, okay. So pu- A pulls it eastward like this. Okay. A pulls eastward with 200 newtons. B pulls southward with 100 newtons. So B pulls southward with 100 newtons. Okay, like this. This is B, this is A. And C pulls at an angle of, so B pulls southward and C pulls with 300 newtons force at an angle of 35 degrees west of north. Okay. So what is the net force caused by A, B, and C? Okay. So we can do like this, better view. This is FA, 200 newtons of B, 100 newtons. And this is 35 degrees. Okay. So this will be, so F, uh, this is, so we'll decompose FC into X and Y directions. So this was FC. Okay. So we can find the X and Y components of it. So this will be, X will be FCX and FCY. So FCX is FC sine 35 degree. Okay. And it is in towards left or west, so it will be negative. So this will be negative 300 degree sine 35, which is equal to negative 172.07 newtons. Okay. And when we decompose the vertical component of the C, which is this FCY, okay, this is up, so it will be positive, and it will be FC cos 35 degree. So this will be FCX. Okay, so this will be 300 cos 35 degree. So this will be 245.7. Okay. So net force in Fx direction is equal to Fcx plus Fa. Okay, in x direction, the horizontal component of Fc and Fa, there is horizontal component of Fb is 0, so we don't take it. So this will be negative 172.07 plus 200. So it is positive around 27.92 newtons. Okay. Then the vertical component will be FCY plus FP. It is equal to 245 minus 100 is equal to 145.7 newtons. Okay. So this is the net horizontal force, and this is the net vertical force. Fx is the net horizontal force, and Fy is the net vertical force. So the net force, okay, so Fx is 27.92, okay, and Fy is also positive, and it is 145.7. So the net force F would be, we'll use Pythagorean theorem, and it will be 27.9 plus 145.7. So square. So it will be 148.35 newtons. Okay. And to find the angle, which is here, we do This is the angle theta, which will be Fy, net Fy over net Fx. So that will be 145.7 over 27.9. So theta here would give us, theta would be 79.15 degrees north of east, this angle. Okay. It will be north of east here. Okay. So we'll do the Newton's, now in the next, we'll do Newton's third law of motion, and then we will do the free body diagrams in detail. Okay, thanks for joining.